Problem number 3, we got HF solutions. Cannot be blah 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 because it reacts with silicon dioxide to produce that hexafluoro whatever silicic acid and then water. So we have 40.0 grams of silicon dioxide and 40 grams of that hydrofluoric acid as reactants, and one of the product is that H2SiF6. So part A is asking convert what into what? Well, we got two reactants, so let's write first reactant 40. You know what? I think it's better to do part B, which is writing out the whole reaction here first. Okay, so we got, let me see, we got HF reacting with the other reactant, which is SiO2. It says it's gonna produce that humongous H2. I'm gonna make some space to write the coefficient in a minute because we need to balance it, right? You gotta balance before we do anything, like stoichiometry. Otherwise, you're gonna get it wrong. SiF6 plus water H2O. Okay, these are the molar mass I just found using Google earlier here. So I'm just gonna put that aside for now. Okay, I think that's it, right? We need to balance it now. Let me see how many of each. Let's use a red color. So H wise, H is everywhere, so I'm not gonna touch it. I'm gonna balance at the end. But F is something unique, and Si. Okay, let's see. F, I have 6 on the right side. Let's put 6 here. That makes it. Let me see what else is there. Oh, we got O2 here, so I'm gonna put. Let me see what happens if I put 2 here to make it 2 O's, right? Right. Let me see. I think that should do it. Let me see. 6 H's on the left side. We got 4 and 6 H on the right side, and then 1 Si, 6 F's, 6 F's, and then 2 O's, and yeah, I think that should do it. You have to make sure, okay, like on the test or quiz, if you get this one wrong, you're gonna get everything wrong. Okay. Hold on. Let me just double check. 6X, yup. And then F, 6F's, yup. Si, 1, yup. And then 2 O's, 2 O's. Yeah, that should do it. Now let's go back. Now these are the reactants, right? So let's first change 40.0 grams of the first reactant. I have to put G, right? Grams of SiO2, we need to convert to grams of the product H2SiF6, and we do the same thing with the other reactant, grams of HF into that same thing, grams of H2SiF6. Okay. Now, as you have predicted, if they give you grams of or moles of 2 reactants, like information about 2 reactants, you have to figure out which one's limiting reactant and which one's excess reactant. So let's first assume that we're going to use up all 40 grams of, let me see, silicon dioxide first. Okay, so we start with 40.0 grams of, you know what? If it was, no, I'll just do it. 0.0 grams of silicon dioxide. We have to go from here to all the way up to here, okay? It's 1-to-1 ratio. So molar mass, I already found it. It's 60.08 grams of silicon dioxide in 1 mole SiO2. And then cancel. For every 1 mole, this is where you use stoichiometry, like 1-to-1 ratio. For every 1 mole of silicon dioxide, we have 1 mole of that H2C6, whatever that is. Then let's get all the way up to grams. So 1 mole of H2SiF6. It weighs on Earth 144.09 grams of that H2SiF6. Okay, and they all cancel. All the units cancel except that unit right there. Okay, so take out your calculator. Well, first of all, you should try this by yourself first before you actually watch this. Okay, here we go. 40 divided by 60. And if I do something wrong, can you any of you leave comments saying I'm wrong? I get things wrong all the time. So that's 95.9. Let me see. 3 sig figs, so 95.9. How about that? 95.9. And then grams of that. I'm not gonna, yeah, whatever that is. Okay. So that we'll have to let me change color. We have to do the same thing, but then this time assume we use all 40.0 grams of hydrofluoric acid right there. Okay, we'll do the same thing, but its molar mass is different. So 20.01 grams of HF, 1 mole of HF, and ratio is different now. Look at the stoichiometry, right? It's 6 to 1 now, right? So every 6 mole of HF, we're producing 1 mole of that H2SiF6. So cancel. And from here, same thing. 1 mole of H2SiF6, 44.09 grams of that. I'm a little bit hesitating because I didn't want to write that all the time. And then, again, calculator out. 0.09 divided by 20.01 divided by 6 gives me 48.36. So 48.0 grams of, this time let me write it, H2SiF6. Okay, so we made, using HF all the way, we made less of it. That means, if you don't know this by now, I strongly suggest you drop this class. All right, so it made less of it, so HF, okay, is the limiting reactant. And then the other one, HF, no, maybe I should drop it. Silicon dioxide is excess reactant. So theoretical yield is, this is what you're supposed to get, 48.0. So that's, so what you're supposed to get, right? And then everything else is complete, like perfect. All the experiment, all the experimental procedures perfect. When everything's ideal, you should get 48.0 grams of it. Okay, but in reality, it's not. You see right there, they reacted, and look at the problem here. It only yield, usually it's always going to be less. Not always, but yeah, usually it's going to be less. You only yielded 45.8 grams, where the theoretical yield, what you're supposed to get when everything's ideal, you should get 48 grams, okay? So, and then multiply by 100%, I'm not going to do that here. So it's like if you got 45.8 points on the quiz and the total possible point is 48, what's the percentage? It's just like that. So what you want to do is 45.8, and you get that from the what is it, a problem right there. It's stated. That's experimental yield divided by what you're supposed to get, 48.0. So that's 95.4%. 95.4%. So that's the percent yield. Let's do the next problem now.